What up, Chem Gang? It's Jeremy again from the chemistry, and we're continuing our series on states of matter. And today we're going to be talking about liquids. And to help me demonstrate, I have this lovely cup of water. Okay, so let's get into the properties of liquids. Liquids have a fixed volume. They take the shape of the container that they're in. They can compress and expand slightly. Emphasis on slightly. The molecules inside of a liquid are closely packed, but there are gaps that do exist between molecules. And that can be seen here in my diagram, where we have a few gaps existing between the molecules. And lastly, arising from that, the motion of the particles are such that they can move, molecules can move where gaps do exist. So when we're talking about the forces of attraction that exist between the molecules of a liquid, the best way that I like to describe them is not as strong as the forces of attraction inside of a solid, but not as weak as the forces of attraction that exist between molecules inside of a gas. So the best way that I like to describe them is it's situational, wherein you describe them as either being strong enough or weak enough. And we'll see as we go through here now. So first of all, the molecules inside of a liquid are closely packed, but there are gaps that exist between molecules. Now, why is that? They're closely packed because the forces of attraction are strong enough to keep molecules close together. However, they're weak enough that there still exists this ability for molecules, for there to be separation between molecules, right? And now that leads on to the next part, where the motion of the molecules is such that the molecules can move wherever there are gaps that are available. And that's because the forces of attraction are also weak enough that molecules are not forced to be kept together so that all they can do is vibrate like in a solid. No, in a liquid, the molecules are able now to have some level of freedom because the forces of attraction are weak enough that it allows for that. Now, when we talk about liquid's ability to compress and expand, we said it's very slight. If you were able to get a container that you could kind of close in from one end to the other, like a piston, you would realize when it comes to compression that there comes a point for liquids where you can no longer compress it anymore. Now the reason for that is because a liquid, like our cup here, like the water in our cup here, inside of this there exists some gaps, some space. So what we can do is we can compress it so that we push the molecules into their closest proximity and there are no spaces. Now when we get to that point, we'll find that we can no longer compress the gas because the molecules are in tightly together and they are not going to be compressed or pushed any further. Then you have the expansion. If you were to put a droplet of water on the table and take your finger or a pen or whatever and kind of try to stretch it out, the liquid would go a little bit with you, but not enough. Now the reason for that is because the forces of attraction are weak enough that you can expand it very slightly. It'll go just a few little inches of a millimeter or a centimeter or whatever. However, the forces of attraction are strong enough that it's not going to allow you to completely remove the molecules as you wish, you know. Then the liquid takes the shape of the container that it's in. Now the reason for that is because the forces of attraction are weak enough that molecules are able to flow wherever there is room for them to flow. So that's why if we were to take this cup of water, transfer it from this flat shape into a container with, let's say, a curved shape or a cone shape, as long as the liquid has the ability to flow into that region, it will. So it will take on the shape of a conical or a curved container or whatever container it goes in, as long as it can flow into that region. And the volume remains fixed. Now, if I have 50 mils of this water, it will remain 50 mils no matter whether I pour it into a different container or the shape of the container changes. The reason for that is because, again, The forces of attraction inside, between the molecules inside of a liquid are strong enough that molecules do not have that full freedom of motion that they can just go off wherever they want. No. The forces of attraction still keep them close enough together that the volume of the liquid would remain the same.